Okay, here's a Foley S8B. It's actually a rebranded Wissota skate sharpener from 1977. It's called the S8B for skate, 8-inch wheel. The B model changes it's got a cast iron plate and also has a better way to adjust the radius of curvature. 3450 RPM, 115 volts. It's a 2.2 amps. The 911 is actually 3.2, so this is probably about a quarter horsepower motor. I think the other one's roughly about a third. 60 a cycle. Here's the date code. W12 is 77. It's December 1977. Okay, down over here, this is the on-off switch. This is a cast iron. Motor's set in here. There's a notch down in here where they adjust the Z height, so that can be moved up and down. Over here, I'll show you on the top here, this piece here in a second. There's a distinctive notch on the side on the S8B model, and that's for the radius of curvature piece that goes in here. The 911's out in front, the diamond. If it's on the side, it's a S8B, which is this is a 70s model. I think these went up into mid-80s. I'm not sure exactly when the 911 came out. So this is an older model Wissota. Okay, this is the adjustment that moves the pivot point back and forth. It's on the back of the machine. And then this has got two different sets of holes on here. So this will bolt in here, or it'll bolt in here. So you can move this fore and aft, side to side, with this knob here. And then you've got this position. And then you also have this 3 32nd inch piece that you can undo to move the diamond back and forth. Now, where the radius curvature is dependent on this pivot point to this diamond. So if you visualize this swinging back and forth, you project a line, and whatever the distance is from the diamond to here, I've got actually stuck out too far. That's what the radius of curvature is for the radius of hollow. I can get in here and move this back. So if you projected a line through here, if that was a half-inch gap, that's a half-inch radius of hollow. Okay, right here, there's this knob, moves this piece back and forth, and I haven't got the pin in here yet, or the bolt that holds this plate down. But when you spin this around, it moves this brass piece back and forth, and that has the bolt for the swing arm here for the diamond goes in there. So when I turn this, you can see that edge there. This is moving in respect to this. And what you have to do is you have to adjust that, because as the wheel gets smaller, you got to move the diamond closer. Because the wheel will get smaller as you sharpen a bunch of skates. So I'm putting the screw in here that holds the pivot point. It has two different places you can put it in, and you can change that as the wheel gets smaller. So where this rotates around, like in a mechanism, this is called the instant center, where this tends to revolve around. So you can cut very small radiuses of hollow with this. You just kind of have to figure out what you're doing as far as the where the pivot point is, where this dot is here with respect to its rotating about. That is the radius of hollow. Okay, we're looking at the back of the machine. This knob moves this steel piece back and forth. These screws on here need to be snug enough that there's not that much play onto here. they're too tight, you won't be able to drag it and you'll strip out this bushing. So you want it tight so that this is not going to dance around when you go ahead and cut the radius of hollow on here. You've got two positions for this, and you also have another in here. There's a hole here, tapped hole here, there's two through holes. So probably in another video I'm going to figure out what the range of the radius of hollow is on this, because I haven't used one of these in a long time with anything serious work. If this is loose, see, like this, it's gonna dance around when you're trying to cut this, which isn't good. So you almost need to keep one of these handy so it's snug, but not too snug. You can go back and forth and trim this. Of course, the new model of 911, you've got just a mark on here for what the radius of curvature is. And the curvature on that is from this point to the pivot here. I believe it uses the same diamond. I'm not sure if the adjustment is the same. I'm not sure if you put one on here with the measurement on here, it is the same. But you can project a line from the pivot point. So right now this is about a 1 inch through here. And if I move this forward like this to where the stone is, then it's a narrower radius of curvature. So you got a lot of stuff going on here. This is 3/32. Of course, you never want to move this and crater this and hit the stone with too much force and go through and bust the thing off. So you always have to be aware where this is. And this is shown with an 8-inch wheel here on there. So as the wheel gets smaller in diameter, you've got to go through. Here's a wheel's been ground way too small. You've got to move this thing forward so you can go through and move this all the way back. This has got to travel here of about 1 inch through this slot. I'll probably do another video some other time to figure out what the practical radius is of hollow on this.